So, in this one we have a vector equation of a line, and the question asks us to find the normal vector representation of this line. Now first of all I'm going to find the normal vector representation quickly just from this line, and then we'll find all of the other forms. So, the normal vector representation is of the form n times x is equal to n times p. This is how we can find the normal vector representation, where this is the normal vector. This x, as in the last video, represents any point on the line. So it stays like this to represent the coordinates x, y. N again is this same normal vector as we've had over here, and p is a specific point on the line, and we find the scalar product of this point with the normal vector to come out with a number on this side. So this side here should just be a number, and that becomes the number that then can be found using any point on the line and taking the scalar product of any point on the line with the normal vector. So we have two things to find. First of all, the normal vector, and second of all, this number here, which we can get by taking the scalar product. So the normal vector is easy to find. We have here, in the equation of the line, the vector equation of the line, we have the direction vector, and this goes in the direction of the line. From this, we want to find the normal vector. Or any normal vector. So this vector is perpendicular to the line. So if we find a vector that's perpendicular to this direction vector, it's automatically a normal vector for the line. And this is exactly the same trick as we used in the last video. We can just turn these upside down and change the sign of one of them to be the opposite sign. And then we have a vector by which, if we multiply this using the scalar product, we come out with 0. And that means that the two vectors are perpendicular. So we can take n as being 3, 1. Because then I have 3 times negative 1 is negative 3, plus 3 times 1 is 3, negative 3 plus 3 gives me 0. So this is our normal vector. So I already have 3, 1 times x is equal to, and now I just need this number. And I can find this number by multiplying this normal vector I found by a specific point on the line, and it just so happens that this vector equation of the line gives me a point ready-made. So I can do 3, 1, scalar product of that with the point 1, 2, and I get 3 plus 2, which gives me 5, which gives me then 5 there. So that is then my normal vector representation done. And from this, it's really easy to find the other forms. So I have 3, 1 times the point x is equal to 5. As I said in the last video, this x is equal to the coordinates x, y. So I just take this scalar product to get 3x plus y is equal to 5, which is our implicit form. And then I can just rearrange this. If I take off 3x, I get y is equal to minus 3x plus 5, which is our explicit form. And then we're done. We have all the different forms of the line. I hope this one was also helpful. If you haven't watched the first video about how to change the normal vector representation form to the vector equation before this one, and you're a little bit confused, I'd recommend going to watch that video then again, or first, because that should explain some of the things that have been used in this video.